Hi ladies and gentlemen, welcome back again. This is chemistry. Now in this video we'll be looking on organic chemistry. We'll be looking on the questions that were in the last year's paper, that is Kcse chemistry paper 1, that were on organic chemistry. So the first question that was on organic chemistry was question number 5. So the question reads, the structure of a compound is, this is the structure of that compound. The question is, give its Roman 1 name, it had 1 mark, Roman 2 empirical formula. So we know in organic chemistry we have 3 kinds. We have the first one is alkane, which the general formula is CnH2n plus 2. Then we have alkene. The general formula of alkene is CnH2n. Then we have alkynes. The general formula of alkynes is CnH2n minus 2, where n is equal to 1, 2. So n are just natural numbers. So we know in alkenes we have a double bond. Here we have a double bond. And in alkynes now here, alkynes, this we have a triple bond. Sorry, this we have a triple bond. Now because when you come back to the structure, we look at the structure, we have single bonds. And this alkane, the first group now, it's single bond. We have a single bond. So basically to get the name, we know the structure now, it is alkane, sorry. So we count the number of carbon now because we have known the group, it is alkane, where CN2N plus 2. So we count the number of carbons, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now because there are 10 carbons, each with a single bond, bonded to a hydrogen, now we know the name should be decane. Decane, that is number 10. So the name is decane. This is the correct name. So the name is decane, sorry. Yeah, the name is decane. Number 10. Okay, let's go back to the other part. Roman 2 is empirical formula. Empirical formula. Okay, let's start with molecular formula. How do you get the molecular formula? To get the molecular formula, you come back to the structure and count the number of carbons. We have found that the carbon are 10, and hydrogen, when you count them, you'll get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Hydrogen are 22. So this is the molecular formula. But we know empirical formula is equal to a half of molecular formula. So empirical formula is a half of molecular formula. So in other words, it is a half of this one here. I'm opening a bracket, carbon 10, hydrogen 22. So in other words, you are supposed to take the carbon which are 10 divided by 2 and hydrogen which are 22 divided by 2. So you will get carbon 5, sorry, yeah, and then hydrogen 11. So this is the empirical formula. This is the empirical formula. Yeah, let's go to part B of the question. Part B says, draw the structure of an alkanoic acid whose molecular formula is, we have 5 carbon, 10 hydrogens, and 2 oxygen. So we know alkanoic acid, the general formula is R carbon. This is the general formula. If we if you write it in another way, is we have the R part, then carbon, then the carbon, you have a double bond, we have an oxygen, then a single bond, oxygen and hydrogen. This is how we write alkanoic acid. In fact, we have alkanoic acid and alkanols. So, but now we are dealing with alkanoic acid. So this is the formula. So when you come back to the formula, we have five carbon. So we start draw the carbons. 1, 2, 3, 4, 5. Then we know the last carbon should have a double bond and an oxygen according to the general formula now. Then we have a single bond and oxygen and a hydrogen. Then we replace, we are told we have 10 hydrogens. So you can start saying, drawing the hydrogens now. So we have done the hydrogen. Now we can count it. We have 10 hydrogen here. So count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the hydrogens are 10, carbons are 5, 1, 2, 3, 4, 5, oxygen are 2. We have this one and this one here. So that this become the structure of the alkanoic acid. Yeah. So the next question on organic chemistry was question number 8. So the question reads, the mass of one molecule of a hydrocarbon is this one here. Now we are given the Avogadro's number. We use this one. We are told carbon is 12 and hydrogen is 1.0. So question 8a, determine its Roman 1 molecular mass. So we have to know that we know 1 mole is equal to 6.0 multiplied by 10 raised to 23 per mole. That one means per mole. But we are told the mass of one molecule is this one. So what you do, you'll come and write what about 9.33 multiplied by 10 raised to negative 23 grams. So what you do, you cross multiply. So this one becomes, you will take 9.33 multiplied by 10 raised to negative 23 grams multiplied by 6.0 multiplied by 10 raised to 23 per mole divided by 1 molecule. So we know this one and this one, they'll cancel. This one and this one here, they'll cancel. So you remain with 9.33 multiplied by 6.0 gram per mole. Now here you use your calculator, you will get, you use your calculator, you will get 55.98 grams per mole, which is approximately 56. So this is the answer. Yeah, the approximation of this one, when you want to make the whole number, we round it off, it becomes 56. So that is the molecular mass. So let's go to Roman 2 of the question. Molecular formula. So you determine its molecular formula. Now here we have said, the question carried 1 mark, we have said we have alkene. We have said the molecular formula of alkene is CnH2n plus 2. We have alkyne. We know the molecular formula is CnH2n. Then we have alkenes, the molecular formula is CnH2n plus 2. And we have been told here carbon is 12 and hydrogen is 1. So, and we have the molecular mass from 101 is 56. So what we do is we try alkane. If it okay, look up here. What we do is we know carbon is 12, so we'll start with alkane. 12 multiplied by n, which is 12 multiplied by n, plus hydrogen, which is 1. 1 multiplied by 2n plus 2 is equal to 56. We will get 12n plus 1 multiplied by 2n plus 2. We will get 2n plus 2 is equal to 56. Here will remain with, when you add 12n plus 2n, that is 14n plus 2 is equal to 56. So you take this 2 on the other side, you remain with 14n is equal to, when we plus here, that means remain is equal to 54. When you divide by 14 here, divide by 14 here, basically you get n is equal to, here also use your calculator, sorry, you will take 54 divided by 14, you will get 3.8, which is a decimal. We don't need that. We need a number that will give us a whole number. So we try the other one. Let's go to the second one, alkene. We know alkene is CnH2n and carbon is 12, so it's 12n plus hydrogen is 1. 1 multiplied by 2n, that is 2n, is equal to 56. So 12n plus 2n, that is 14. N is equal to 56. So n is equal to, you'll take 56 divided by 14. Use your calculator, that is 56 divided by 14. You'll get 4. So n is equal to 4. Now, because we have gotten a whole number, it means this hydrocarbon is an alkene. So basically, we know the molecular formula will be, because n is 14, it is C4H2n, that is 2 multiplied by 4, that is 8. So this is the molecular formula. Okay, let's go to the other part B of the question. Draw the structure of the hydrocarbon in 8a. So we draw the structure of this one here. That is, and we have said it is from this part here, alkene. So we know the molecular formula is C4H8. And remember, alkene, they have a double bond. So we have to remember that. So first we draw the number of carbons, that is 1, 2, 3, 4. There are 4 of them, and I've said they have a double bond, and we make the double bond to be the least number possible. So we can choose the double bond to be here. Then we have 8 hydrogen. So for this first carbon here to be stable, we have 1, 2. There have to be 4 bonds. 1, 2. So you have to replace one hydrogen here. The 1, 2, 3, you replace another one so that we can be stable. Then the second carbon here, so this one is stable because we have 1, 2, 1, 2, 3, 4. The second carbon here, we have 1, 2, 3. That means we only have to add one hydrogen for it to be stable. So we have 1, 2, 3, 4. This, the third carbon here, we have to add a hydrogen here and a hydrogen here, so that we have 1, 2, 3, 4. It is stable. And this one here, we have to add hydrogen here, a hydrogen here, and a hydrogen here, so that it becomes stable too, because you have the first bond, the second, third, and the fourth. So when you count, we have 1, 2, 3, 4. Then the hydrogen are 8. 1, 2, 3, 4, 5, 6, 7, 8. So we are correct. So this we can name it as butene or You can say it's but 1 in. Both of these names are correct. But we are told to draw the structure. The structure is this one here. But the name is butene or but1 in. But1 in because the double bond is on the first carbon. Okay, the last question on organic chemistry was question number 14. So the question reads, give an example of a natural polymer made of Roman 1 is cellulose material, Roman 2 is hydrocarbon. So we know an example of a polymer that is made of cellulose material is, we have cotton, or we can have paper, or we can have wood. Yeah, that's what was to have a mark. You can write any of them. And a polymer made of hydrocarbon, we know is natural rubber. Natural rubber. Okay, part B of the question. Part of the structure of perspex is, this is the structure. Then we are told Roman 1, draw the structure of the monomer. We had one mark here. So basically monomer is a repeating unit. So we can look here, we see we have the carbon. This looks like what do we call it? Yeah, we have this structure here. Then it looks like it is repeating here. Yeah, it looks like carboxylic acid, carboxylic acid. So we have this structure here, this one here, and this one here. They are repeating. So when you're told to draw the monomer, then you pick one of them because you look on the repeating units. So basically we have a carbon, then we have carbon, 2 hydrogens, CH3. We have a hydrogen here, we have a hydrogen here, we have a hydrogen here. But we know, so this is the repeating unit. But remember, this unit is not stable here because we have, if you look at here, we have a bond 1, 2, 3. So to make this one stable, you have to add another bond here to look at a double bond, so that we have 1, 2, 3, 4. So the first carbon is stable. The second carbon, we have 1, 2, 3, 4. So the second carbon is stable. So this is the monomer. That's the structure of the monomer. Then Roman 2, that is Roman 2 of part B, give true properties of perspex that make it suitable for use in making lenses or properties. So the first property is it has a good transmission property. So we are saying has a good transmission property. Transmission properties. Over 2, perspex is transparent, hence high optical clarity. We are saying it is transparent, hence high optical clarity. Then that is 2, but I can add you another one. The last property is that it is free from change of refractive index. Free from change of refractive index. So those are the questions on organic chemistry. Make sure you subscribe to the video, like the video, and comment on the video. Let me see on your comment how you view this video. The next part we'll be looking on other questions in chemistry that were on the last year's paper. Thank you.